let's hear some votes and quantification. Not Danielle, hang on. Start with D, start with M. Madeline. Madeline's over somewhere else. It's not here. 2 syllables.
Michaela.
3 syllables. Michaela. Damn. Michaela, who's better?
I think Ernie is better because...
Ernie is better.
Yeah. I feel like Bert kind of cheats sometimes and his cheating partner isn't always by him.
Whoa! Whoa! Careful! Use those numbers and only those numbers and assume they're fair. Oh my God!
Well, because they're so like bound like
That gone. You cannot say he's cheating.
Okay, well,
Because he does well. What if his kid was up sick the night before?
They just fluctuate and it just
Seriously?
Ernie is more consistent.
Okay. I'll put you back on the board, Michaela. Cheating. So Ernie is more consistent. Measure it for me.
That his average is 81.
His average is 81?
Both of their averages.
Both of their averages are 81. Okay, so let's do this. I'll put it under here. So we got Bert, and we got Ernie. And they both have the same average of 81. Interesting. Next bar, 81 points, 81 points. So actually, I'm going to pause your answer just a second, Michaela. Anybody say they're the same based on that? They're the same student. Got the same average. Same student. Did you guys did you do the medians?
Yeah.
About the same?
They're about the same. Bert was 82.
Bert's 82.
And Ernie's 81.
Ernie's 81, so that's about the same, yeah? That's about the same as far as median goes. I mean, it's 1 point off. But, I mean, if you're assuming this is out of 100 points, which I didn't mean it to be out of 100 or anything, that's 1 point difference, so I can live with that. I'd call that the same. So this is reinforcing they're the same. Jim walked in and asked a very, very popular question from students. Can we drop the lowest score? Well, sure, but statistically, you should also drop the highest score. Because you should remove any flukiness, including a fluky high score. Because I think, going back to Michaela's cheating methodology, that the 61 might be fluky, but so might the 100. So if you remove the flukiness, you could actually do what's called a trimmed average. A trimmed average. And I'm going to have you guys explore this on your exam. I've got an Excel command that actually explores that pretty well. What we'll do is we'll chop off the lowest and highest from each of them. Because technically speaking, I know it's not nice when you're calculating an average as a student to have your highest grade thrown out and your lowest grade, but statistically it makes the most sense. Because if your low grade is truly flukily low, that means you should have more high grades than low grades, yes? So losing a high grade your average should not rely on one high grade. It should rely on the normal modal high grade. So losing one and losing the bottom isn't going to change your average in a negative way. It's going to change it in a positive way because it's going to slide back up towards that mode. Remember the real estate prices? Kind of in the inverse. There were fewer higher, but there were chunks of low. So if we threw out some of the low and some of the high, the average moved towards the low.
But their
They were
average was the same.
Say that again.
Their mean was still
Oh,
the
that's
same.
what I'm saying. That's what I'm saying. If the 61 was fluky, and we throw out the high and the low, let's see what happens there. I'm totally with you. So what would Ernie's trimmed mean be if we threw out this high and this low?
81.
It's still 81. That's Ernie, right? 81. How about Bert?
81.3.
81 point, got a .3? That's Cody. Cody?
Yeah.
Cody, 80.3? Call it 81.3, that's totally fine.
The other one was 81.3 too.
They're both 81.3?
I like 81.
I don't.
I got 81.
Now, the only reason I can do this is because the numbers are so easy I can do it in my head. If you throw away that one and this one, it's got to be 81. Because if we do the sharing lollipops, he becomes 81, the extra one goes to that, and they're all 81.
Okay.
That's the only reason. I couldn't do Bert in my head. Thank God Cody did for me. I didn't have to worry about it. But so yeah, looking at this, who's better?
They're not the same.
They're the same. Looking at the measures of center, yes? Looking at the measures of center, there's no modes. We don't leave the mode out of the discussion. But looking at the idea of balance or positioning around a center point, balance in the tray, lining up and finding the middle, there's no difference. But there is a difference. Michaela's pointed it out already. I want to let the cheating thing go away. and go with the Ernie's more consistent comment, which I love, by the way. Who else thinks that Ernie's more consistent? That's like 2/3 of the class. Excellent. Quantify that for me. Quantify. You stand, perhaps. Let's go over here. Careful! You don't know that. All you know is he got an 82, an 81, and an 83. You have no idea what's going inside his head. You have no idea what's inside his head. That's what's so dangerous about only looking at, say, 5 test scores to try to decide about a student. There's a reason I give you guys a bazillion assessments, and many of them you're writing out reasonings, so I can see inside your head. All I know is, these are the scores Ernie got, these are the scores Bert got. I have no idea his comprehension level. All I know is he's getting these scores on tests.
Well, that shows kind of his comprehension level, doesn't it?
I don't know. I mean, maybe it does, maybe it doesn't. All I have is 5 numbers. I'm trying to indicate something from those 5 numbers. So actually, Kelly, you bring up a good point, though. Let's make a definition. A higher score is better than a lower score. How about we say that? So clearly 100 is the best score we see on the screen. 61 is the worst score we see on the screen. I said, let's come halfway. Because I really can't, I can't see the assessments themselves, so I can't tell about comprehension. But I can tell that Ernie got most of his scores around that 81 tightly, and Bert didn't, which I think is what McKenna was talking about back there. Can anybody quantify the idea of consistency? Wait.
Katie.
Damn it! Let's say Linda.
Sorry.
Where's Linda? You're over here. There's no Linda in here. There's Linda. Good. Okay. Katie, Linda. 5-letter words messing with me. Go ahead, Katie.
Well, Ernie only has a 4-point difference between his low and high score.
Good.
And Bert has a 39-point difference.
Oh, how to measure? Because this is really, friends, this is what statistics is all about. It's when you have a belief like Ernie's consistent, or more consistent than Bert is. It's how you quantify that belief. We did an experiment in 244 this morning on touch therapy and the human energy field, which some of you may have heard of and most of you probably haven't. If you take 244, we'll do the experiment with you guys. And the first question that somebody asked me was, before we finished the experiment, do you believe in this? I'm like, I don't know. They're like, what do you mean you don't know? I'm like, well, that's why I'm collecting data, to see if I can believe in it or not. You see what I'm saying? Statistics will give me a measurement for a belief or lack of belief. This is why I'm so, that's why I give you 5 quizzes a week, or whatever it seems like I'm giving you. I give you so many quizzes a week because your life is surrounded by these statements. Whether or not the statements hold up to scrutiny is the question. In order to hold scrutiny, you have to quantify it. That's what we're trying to learn how to do right here. So how do we measure this idea of consistency? Okay, good. So one way is this idea of, so what Katie did was put the high and the low and the difference of them. That's actually called something statistically. It's called the range. It's called the range, which is just the high score minus the low score. High data point minus the low data point. And we'll go over here with Bert and Ernie, we'll keep a secondary. This is kind of like the measure of center chart over here, which is great. We'll come over here and do the measure of variation chart. So we got Bert, and we got Ernie. So as far as the range goes, Bert's, his high is 100, his low is 61. His range, therefore, is 39 points. Whereas Ernie's goes from 83 down to 79, which is only 4 points. So what's nice about that is we actually have a quantifiable measure to show the difference between them. Although the centers that were listed over here don't show any difference, the ranges actually do. It looks like Bert's 10 times as variant when you look at range as Ernie is. 10 times as variant. I mean, 30-ish. 39 is like 40-ish. So 40 is about 10 times 4. Does that go with your gut as far as consistency goes? Yeah, that's a great measure, I think. Fantastic. Good. Often used. Not often used what's called inferentially, but often used in conversation to get a rough idea of how spread things are. Good. Can anybody see how range could bite you in the butt? How range might not be a good indication of, I think it's a great indication here, especially how the scores fell out. But can you see how range might be misleading? JT, what are you thinking?
Well, it just depends on what would be consistent. Like, there could be a wide range.
Good.
Of consistency.
Well, yeah, we haven't really lined up what consistent is. Hold that thought. I'm thinking in about an hour we'll be ready to actually lay up some rule guidelines, I guess. Let me ask a question. Suppose Bert had test scores not like they are up there, but suppose instead Bert had test scores that were 61, 100, 100, 100, 100. Do you think it would be fair to speak of his range then? Because what would his range be?
It'd still be.
It would still be 39, wouldn't it? Because he has that 161 and a bunch of hundreds, which means the high minus the low is still 39. Now, of course, this would also change over here if we had that situation. You wouldn't have the issue that we had before with the centers being the same. But as far as measuring variation, what's the tiniest problem? And it's a minor problem, but what's the problem with using just the range to talk about variation?
It rules out.
Go ahead, Janelle, go ahead.
I was going to say, wouldn't the 61 be considered an outlier?
In that case, it would be very, very good. But the problem is the range depends on the low and the high. What does it ignore?
Everything in between.
Everything else. It ignores everything else. That's a problem with the range. It's a minor problem sometimes. In cases like this, it's not that much of a problem because 61 is not an outlier by definition. We'll get to that in a couple weeks anyway, what an outlier is, once we get some more fundamentals under our belts. But in the case where you do have outliers, the range can be artificially inflated because the outlier pulls the range too wide. Good, very, very good. So can anybody think up another measure? I'm saying make one up now. Make up another measure that would consider every single data point. This might help you. This might help you. Here's a dot plot of their exam scores. All right, put them